So hello guys, this is Bhivash, and today I'm gonna discuss about dynamic programming, which is the most famous topic for competitive programming. So first, instead of discussing what is dynamic programming, today I want to share about why dynamic programming is important. So first of all, dynamic programming is simply important to reduce our time complexity. So let me give you an example. We all know Fibonacci series like 1, 1, 2, 3, 5, 8, and so on. And we all know there exists a recursive solution for this problem, that is, if n equals 0 or n equal 1, we simply return 1, or otherwise we return f of n minus 1 plus f of n minus 2. So this solution is okay, but it has some problem. So let me discuss about the problem with the recursive solution. Let me remove it. Okay, so first of all, we will see for f of n minus, for f of n, we have, sorry, f of n minus 1, f of n minus 2, and for f of n minus 1, I think there is some problem with print. So f of n minus 2, again we have f of n minus 3. So and then that's how we are gonna calculate f of n. So what is the problem with this solution is, here we see for f of n minus 2 we have calculated here, and again we're gonna calculate f of n minus 2 here. As recursion calls are stored in the stack, there is no mechanism to store the recursive calls so that we can reuse it. If we reuse it, we can save lot of time. As we see, f of n minus 2 will involve other recursive calls also, like f of n minus 3. Here you see, here is f of n minus 3, and if we can store this value, we can reuse it here, and that's why we are redundantly calculated these values. We can just because we can't store it. If we can store it, we can reuse it here also, and that's why dynamic programming comes here. Dynamic programming can store this value and we can reuse it to make our solution faster. So how much time this solution takes? Let us calculate it. Let me remove it. Okay, so it grows like a T structure for like f of n. We have f of n minus 1, f of n minus 2. So for the first step, we have one, and the second step we have 2, and for the third step we have 4, and that's how our tree grows. So for the time complexity is order of 2 to the power n. So let me discuss about how much time it will take if we have n equal to 50. So for n equal to 50, it will take 2 to the power 50, order of 2 to the power 50. So to show how much large this value, I will show first that how much time our computer takes to execute one instruction. So our computer can execute 10 to the power 8 instructions per second, and we all know 1000 is nearly equal. Don't know what is the problem with the paint. So 1000 is nearly equal 1024. So that's why we can say 1000 is 10 to the power 3 and 10 to the 1024 is 2 to the power, sorry, oh, I didn't change it. Oh, that's great. So we can say that 10 to the power 3 is nearly tends to 2 to the power 10. So from this we can say that 2 to the power 10 to the power 5, which is 2 to the power 50, is near to 3 into 10 to the power 5, that is 10 to the power 15. So our computer can execute 10 to the power 8 instructions per second. So, and here we have 10 to the power 15 instructions. So our computers, it is just an approximate value. So our computer takes 10 to the power 7 seconds. And we all know in one day we have 86,400 seconds. So if you calculate 10 to the power 7 divided by 86,500, you get 115 point something. So this is the problem. Our solution gonna take 115 days to calculate one Fibonacci number. Yeah, what do you think? It is gonna help us in real world? No. So we have to invent some mechanism to optimize it, and that's why dynamic programming comes here. Now I am gonna give you one coding example. So let me give. Here we made two solutions. One is the recursive solution and another one is DP solution. So here we just mentioned the n equal to 50, and here we are calculating the Fibonacci number, which is for n equal to 50, the 50th Fibonacci number. So first of all, here is the simple recursive solution, which name is Fibo, and here is the DP solution, which name is Fibot. So first discuss about the recursive solution for this problem. Then make it and run it. Sorry. You are seeing that our program is running. It will go and gonna never end, because it maybe there are some segmentation fault that maybe comes in our if you use Sublime Text, there must be some segmentation fault, because our computer don't have much memory, and the recursive call involves lot of memory. So for one way it will exceed your memory limit, and also you exceed your time limit, as it takes 100 and at least 115 days to calculate this solution. So let me give you the example with the DP solution. So I'm not gonna discuss about the how the DP solution is implemented, and that's all. I just run it. Okay. So oh sorry, I need to change the function name. Here you see that this is not the correct solution, but at least one solution that is come. To show you my solution is correct, let us make n equal 5 as of now. So you'll see that there is 8, which is the 5th Fibonacci number. So this is the overview why dynamic programming is important, and what is a real, I give you one real life example why dynamic programming is important. So thank you guys, keep watching, bye bye.